Hi, my name is Nurfaza Nadaini and I'll be explaining about definition of torsion. In the field of solid mechanics, torsion is the twisting of an object due to an applied torque. Torsion is expressed in Pascal or an SI unit for Newton per square meter, while torque is expressed in Newton meter.
Hi, my name is Nordiana Bitizaba, and I would like to present the objective of our project. First, the objective is to determine the behavior of materials when subjected to torsion. Second, to obtain some of their mechanical properties. And the last objective is to analyze the force members from the structure.
Hi, I'm Natirana Jabedikar Zaman. I will be continuing the presentation about the free body diagram and the calculation. From the FBD, we can see that there is force acting at two sides, so that it will be rotating the part.
Next, for the calculation and result,
We will be assuming the value of F1 and F2 is equal to 95 newtons and the force of safety to be 4.7 gigapascal. From the length and diameter, I have measured the device and length and get the length is 18.5 millimeters and the diameter is 8.5 millimeters. As we can see at the FBD, firstly, we must find the T from the equation of equilibrium where the moment is equal to 0. So, we get our T is equal to 4.75 newtons meter. Next, we will find the angle of twist using the formula J equal to pi over 2 times C the power of 4 where C is our radius. And we get J is equal to 5.125 times 10 the power of negative 10 meter. After finding the value of J, we need to use the formula TL over JG equals to theta to find the value of twisted angle, and the value of the twisted angle is 2.066 times 10 to the power of negative 3 radians. Then we need to find the maximum shear stress by using the formula TL over J, and the value of maximum shear stress that we found is 171.46 megapascal. Next, we will using formula maximum shear stress times area, and we get 9.73 kilonewtons. Finally, to find the force felt, we will be using formula of factor of safety where FOS is equal to force felt over force allowed. And we already assumed the value of FOS, and the force felt that we get is equal to 45.73 kilonewtons. Okay, that's all. Thank you.
Okay, for discussion, mechanic of the torque is functioning as the moment of the twisting of an object or structure. When torque is applied to the object or structure, it will twist along the axis, and the larger the shear stress. Since twist is applied with set, the torque will apply shear stress. The relationship between torque and shear is that given torque equal to radius multiply T divided by J. For FOS, we assume that 4.7 in value. It shows that the subject is safe to endure the force applied toward the structure because the factor of safety is bigger than 1. So for conclusion, we can conclude that our mini project can apply our knowledge into how to calculate the torsion and the maximum shear stress. We also can conclude by using Hooke's law principle to relate both strain and stress. As should the maximum strength of the shaft appear to break can be calculated. Every structure has own limit in the during the torsional stress that produced after the force is applied toward the structure, and it called torsional stiffness. Okay, that's all from our project. Thank you.